Hello, everyone. Welcome to this live broadcast of Sheleads in Tech. My name is Lydia Igoche, host and founder of this platform, where our mission is to increase visibility of women in the tech industry. This platform is a space for us to share experiences, knowledge, and expertise on a range of leadership and technical subjects. And today we'll be bringing you an introduction to data science, machine learning, and artificial intelligence led by our subject matter expert, Itoro Liney. Itoro is a data science and analytics manager at Principality Building Society, where her key focus is to help drive data driven decisions. She's also a PhD researcher at KCL London, where her focus is researching algorithmic bias in the financial services sector. Hi, Itoro. Thank you for joining us today.
Hi, Lydia. It's great to be here today. Thank you for having me.
Thank you. It's our very first live broadcast, so thank you for literally opening the show for us. And I'm really looking forward to this conversation. And I have lots and lots of exciting questions to ask you.
Brilliant.
Good. Yeah. So before we begin, we'd like to get to know you a bit better. So can you tell us about you and how you got to this point in your career?
Yeah, absolutely. So I started off as an engineer. I was an electronic engineer for quite a while, and I got into that after I'd done a BEng in electronic engineering. So naturally, I got into engineering. I absolutely loved being an engineer. A lot of my role was in analyzing a performance of microelectronics,
Mhm.
seeing, what's worked, what hasn't worked, and what it hasn't worked, why hasn't it worked, working with
Mhm.
a team of engineers to kind of identify what's gone wrong and put a a fix in place so it doesn't occur again.
Yeah.
So, yeah, that was quite exciting. And during that role, actually, a large part of my role was in data analysis because we were um, a an organization that we um, manufactured a large amount of micro electronic chips and tested them. So we generated a lot of data. And
Yeah.
obviously, the engineers, we needed to analyze it. So a huge part of my role was in this data analysis, which kind of led me to kind of go down an MSc, a statistics based MSc.
Mhm.
And that was really exciting because that just gave me more of the theoretical knowledge to a lot of the analysis that I was already doing in my job, and it opened up my world a lot more. So that kind of, as I said, it opened up my world to other industries who are
Yeah.
doing this type of thing. So I ended up as a customer insight analyst in the financial services industry. So I
Mhm.
worked for a large insurer, helping them to understand their information data on customers, etc. And then I moved into the role where I'm in now, and now I kind of lead a team of analysts and kind of doing the same kind of thing, helping the organization to understand a bit more about the um, data that they hold.
Mm.
So that's it in a nutshell. And as you had mentioned, I'm also doing a PhD part time
Yeah.
because I'm really interested in, a lot of the ethical side of machine uh, machine um, um, learning, and just to understand how that impacts us, and but more importantly, what we can do to identify it and rectify it.
Mhm.
So yeah, so I'm doing that part time as well.
Well done, Itaro. That sounds like you've got a lot going on as well. And what about hobbies? What are some of the things you get up to in your spare time, if you've got any?
Yes. So yeah, no, you're right. There's a lot going on. The hobbies. So I really like hiking, walking. So we go out quite a lot. We walk up a lot of. So where I am in Wales, there's a lot of hills, mountains. So most weekends you can actually find me in the Great Welsh. outdoors, hiking up a hill, and I'm also kind of really into exercising, gymming. So yeah, and that kind of stuff. So yeah, those are like my two main things that keep me um going.
Yeah, oh, that's good. Really important stuff, especially when you've got lots of things going on to look after yourself as well. Anyway, into our topic, introducing data science, machine learning, and artificial intelligence. I mean, just to give a bit of a backdrop to why we're discussing this. So today we're surrounded by data, and data drives nearly every aspect of our lives today. So to begin with, I just wanted you to explain what the role of data is in today's technologies ecosystem.
Yeah, absolutely. Yeah, so that's great. As you said, we are surrounded by lots of, applications, lots of things. Data is used everywhere. And
Mm,
from a tech point of view, all that is essentially these are all the applications um and and systems and things like that that an organization will use to be able to run their operations, right?
mhm,
And one of the things that, as an organization, one of the things that you're interested in is, okay, I've got all these applications and everything, but how do they link with each other and how do they talk to each other? And
mm,
are they effective in what they do? So, what that means is whatever they're meant to do, are they doing it? Accurately, are they doing it well enough? But also, are they efficient in what they do? So, essentially, how much effort is it to executes that thing, and how long does it take, and etc etc.
mm,
So but in order to understand all these things, are you operating optimally? Are you operating effectively and efficiently? You really need to understand how all the different applications, how they all piece to each other, how they talk with each other, how they move information from one to another. Are they
yeah,
doing things right? And the only way to really understand all this is by doing the analysis, and by understanding what the data tells us about it, because that's what's going to inform you as to how things are operating. So
mm,
it's a crucial role, it's a crucial thing in everything that we do, how things link up, because if you don't understand that, then you don't know if you're operating as well as you could, as well as you ought to.
yeah,
So yeah, so I mean, I can't really overemphasize how critical it's it is in the world that we live in now, and it's only going to get more and more so that way.
mm. Thank you, Tara. And does that all feed into creating the body of knowledge that is now known as data science?
Yes, so absolutely, there is a direct link there. So if I think of what data science is, if I think of the two words in there, and 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 science is really about expanding your knowledge and expanding your understanding. And so if I think about it, what we're trying to do is expand our knowledge and expand our understanding of our
Mm,
operations, of our world, um our systems, you
mm,
know so yes, so we're using our data to
mhm,
broaden our understanding, to broaden our understanding of the world that we want, we are interested in. So yes, absolutely, it all links in, because that is the that is what is needed for us to be able to start to gain that understanding.
yeah. And what
The
are some
data.
of those tools? Sorry, apologies.
No,
What
no.
are some of those tools used to gain that better understanding of data science in general?
Yeah, so it's a very interesting question, and it's a question that generally has a lot of controversy out there, right? And my perspective is that the tools don't really matter. I
Okay.
think it's more about the methodology. As long as we understand what we're trying to do and we're doing it in the
Mhm.
right ways, that is what is important. um I think whatever tool you're interested in, whatever tool you're comfortable in, that's fine. If
Mhm.
it does the job, it does the job. Obviously, there's some tools that lend themselves a bit more to doing some jobs easier than others.
Yeah.
So yes, but ultimately it's less about the tools but more about the methodology in
Yeah.
understanding, in that, yeah, how we go about that learning and understanding.
Yeah. So I know you said tools don't matter, but two of the concepts that are popular in the field of data science is machine learning and artificial intelligence. So
Mm,
how does these two tools or methodology fit into the
yeah.
context of data science?
Yeah, I think it's a great question. So I think ML and AI are just they're just another tool in a science tool kit. It doesn't mean that they're it doesn't mean that they're the only ones available,
Mm-hmm.
and it doesn't mean we have to use them for everything, but they're just one of many.
Okay.
And they are excellent tools. They are really great, and they solve a lot of um problems, and that's why it's become more well known in recent times. So
Mm-hmm.
yeah, so the way I look at it, it fits in there because it's a great option, a solid option that we can use to analyze data to understand a
Mm.
bit more. But I think one thing we need to be mindful of and remember is that it's an option. There's other options as well, so we should, it's about looking in that tool. It's about looking in that the chest and
Mm.
finding the right tool. And sometimes it'll be ML would be the way to go down, and sometimes maybe there might be other tools that might help. So yeah.
Yeah. Well, that's good. But just focusing on those two methods of AI and ML,
Mm.
what are the differences, if any, between both?
Yeah, so it's another great question. And the reason I say that is because sometimes we hear those um, terms being used interchangeably.
Yeah.
But the reality of it is that ML is a subset of AI. And if we think about the AI world, I mean, one easy way to think about it is there's broadly two kind of groups. You have
Mm-hmm.
what we call the model driven AI, and we have
Mm-hmm.
what we call the data driven AI.
Mm-hmm.
And ML falls into this data driven AI world,
Mm-hmm.
because what ML is looking at is, okay, let's look at all the historical occurrences, and let's look at our data, and then let's use that to model what we think is going to occur further down the
Mm.
line.
So kind of
But
like supervised learning or such. Is that
yeah,
part of this? Okay.
exactly. But the model-based AI, and I use that term to mean it tries to model the world as it is. So it's not really relying on historical information. We're looking at
Mm.
understanding that world we're interested in, understanding all the agents in that world. How do those agents interact with each other? What are the things that can occur and what are the things that can't occur? And it's by understanding that, then we start to say, okay, how can we then use that to understand what's going to occur, what's likely to occur. So they come from two very different kind of
Mm.
angles. Yes, right now there's a lot of work being done where the two approaches merge a lot more. So there's a lot of like joint research work where you'll get
Mm.
both approaches merging into one, which is great. It's fantastic. But yeah, in a nutshell, We need to think about ML as a subset of AI, and that there's all
Right.
these other AI methods out there that aren't ML.
Mm, yeah. And does deep learning and the concepts of neural network, does it fit anywhere in those spheres between AI and ML?
Yeah, absolutely. So yeah, as you rightly said, so deep learning and um neural networks are just a special type of ML. So they're all still machine learning, because again,
Mm,
what if you think about what they're doing, they're looking at historical information and trying to model it, so they also fall in that group. They are a different type, and just because of how they've come about and what they've been used for, and
mm,
just how kind of a powerful algorithm they are,
yeah.
but they fall categorically in that ML kind of world, that ML, yeah, area.
No, that's really awesome because I think, going into the world of AI or ML, there's quite a lot, especially when you start to look at the various techniques. I mean, even in neural networks, there are different mechanisms. As you know, there's the recurrent neural
RNN,
network, there's CNN,
CNNs,
convolutional neural
yes,
networks, and all of that. So
all
there's
sorts.
there's quite a lot. So it leads me to ask, what is the criteria for determining what model or method is suitable for any given task?
Yes, it's a great question, and I don't think there's an easy answer for this one, right? I think it's one of those things where, as we say here, it's a play it by I can't get the words out. Play it by ear,
Yeah,
which
yeah.
means it's a case by case thing. Some methods, some um tasks, it might be quite obvious, as
Mm,
you talked about, deep deep learning, etc. If we're analyzing things that are like maybe image, I almost got data, or audio, you might that might give a clear indication. You might want to go down the neural networks kind of route. But in terms of all the other things, there's broadly a couple of ways you can think about it. You can think about it in the case of, right, am I trying to understand outcomes? So say, for example, you're an employer and you run a job interview for applicants. You um, hire some applicants, you don't hire some. You might start to think about, okay, if I have a pool of applicants here, who am I likely to employ and who am I
mm,
likely to not employ? So if you have a task like that, you might start
mhm,
to think, okay, it's a supervised learning approach, and then that might lead you down to a group of models that you might start to think, okay, these are the kind of models I maybe need to think about. Or you might be doing something else, which is maybe unsupervised ML, which is maybe you're trying to understand uh, what types of customer exists in your organization, and you want to understand who is more like each other, and who is less like this group, etc.
mm,
So there's different things like that you can think about that might start to make you think about, okay, these are the group of algorithms that could lend itself to this
mm,
uh, um, piece of work. But also you might start want to think of, well, how do I want to use it?
mm,
Do I need something that executes quickly? Am I running it like real time? And is that what I need, or do I have I got the time available to train to take something that might take longer?
mm,
So that's another area you might want to think of. But also there's the information that you have. What does it look like? How is it
mm,
laid out? Some some models might lend itself, some algorithms might lend itself easier to different layouts, different shapes, different types of information. So it's a really difficult thing to, pick out. It's really not a case of if you have this, then do this. If you have that, then
Yeah.
do this. It's not an if then else.
Yeah.
It's a nuanced thing that comes with um time. And sometimes, as I said, it's not everything that needs a big complex
Mm.
um model. Some things might just be if visual is good enough, or
Yeah. Or
so
simple linear regression just
simple
is
linear.
what you need. Yeah.
Exactly. So it's a really played by ear type thing where you just need to experiment a bit.
No, that's really good. I'm going to pick on one of the things you said around how data is used, because you were explaining earlier that if you want to run a supervised task where you collect data from either a group of objects or a group of things you want to monitor, and then your output and categorization is dependent on the data you input into the system. So the question coming up in my mind is, how do we get the right quality of data? And I guess starting to go into the focus of your research, which is preventing algorithmic bias. How do we make sure data is collected in such a way that it's free from bias? Because I think that's a big thing, right? So if you've collected an amount of data which doesn't include certain characteristics, then of course there's no way your algorithm is going to provide a return which says, there's your outcome. So automatically the characteristics you don't include in your sample is automatically excluded. So just tell us a bit more about the work you're doing in algorithmic bias and how that's going to help check that data are accurate and prevent any bias from coming into models.
Yeah. Oh, it's a lovely question. I'll caveat. I'll start by saying
Yeah.
I don't have all the answers, because if I
Yes.
did, my research would be complete. But
Done.
I
Yeah.
can tell you a lot about what I think. When I started this work, right? I
Mm.
started going into it from the the algorithmic point of view. What are the algorithms doing, and which ones are doing what.
Yeah.
And that is very interesting, because some of the work I've done, I can see that different algorithms behave very differently to the same inputs, in terms of when you
Mm.
start to think about a fairness outcome, which is what you are, alluding to there, which,
Yeah.
making sure that groups have a fair outcome. And I put that in them quotes, because the definition of what a fair outcome is it just nobody knows, because it's such what I class as a fair outcome for A, you might
Mm.
not.
Yeah.
But essentially, I started off thinking about it from the algorithmic point of view, but the more and more I researched into it, it all boils down to mostly the data when it comes in.
Mm.
How do we know? How can we, if we're going to fix something, that would be the first place to start to look, to make sure
Mm.
that the data you have is fit for what you're trying to do, it's robust, it's accurate, it's etc. It does what it's meant to do. Um, that is a very challenging thing to achieve. And I think I'm looking at it from another angle, in terms of, well, what is a case of, rather than, as well as working on that, let's
Mm.
try to educate practitioners to understand things to look out for. What are the things that should ring alarm alarm bells? What are the things that should make you go, "Uh oh, hang on a minute,
Mm.
let's dial it, let's rein it in, let's pause, let's
Mm,
go back and look, and let's have the conversation about, is the incoming data right for what we're trying to do? Because
mhm,
the more practitioners we get having this awareness, then the
mm.
more we can start to kind of think about how we can get that input to be of a higher
Quality.
quality. Exactly.
Mm,
You know, I talked a bit about model model driven AI versus data driven AI. In ML, we have a similar kind of thing
mhm.
where we have the model driven ML, which in the past it was just about whatever you get in, let's find the best algorithm to model it. And we
Yeah.
throw enough algorithms at it, and eventually it yields, right? It's going to give you
Yeah.
an answer, and we'll go, yes. And that's like a Kaggle approach of doing, let's try this algorithm and that algorithm and that algorithm. But slowly, I think we're moving away from that model driven ML to more data driven ML, which is a case of,
Mm.
rather than trying to find the best model, let's try and find the best data. Let's think
Right.
about more of the data coming in. Let's make sure it's robust and stuff like that. So it's still, I think it's still quite early, e- e- early days yet,
Yeah.
but I think there's slowly that a a, a shift coming on.
Yeah. No, that's really great. I think for me personally, one of the things I like about model-driven AI or machine learning is that they're ready to use. Although rightly, as you say, it is subject to the designer of that model and the data that model has been trained with. And as you start to move out of that native application for that model, you start to get a different result. So is there a necessity to understand a language in how to train and how to build data models?
I don't think so. I don't think. I think there is a necessity in understanding the limitations of the
Mm,
models. So I think, as again, it goes back to educating the practitioners, in the sense that if you take a model that's just come off from God knows where, you don't know its history, what it's been trained on, you don't know much about it.
mhm.
There should be that um, thought of, will this work for what I'm trying to do? And how can I ensure that it doesn't cause any unintended consequences? And I
Yeah.
think that is because I think it's great to have as you said, the ready to go uh
Models.
models, absolutely, because it just makes it easier, it's more accessible, and people can use it, but I think, right, if you're going to pick one of the two, understanding it, but versus understanding its limitations, I would say understand its understand its limitations, because you will know when not to use it.
Yeah.
I think that's the key thing for me.
Yeah, I think it's tricky because there's so many of them, and when you look at tools like Python, for example, it gives that flexibility in that you can modify, or if you're brave enough, script and write your own model. And this is why I asked the question, because for someone who is starting into data science and ML and AI, I think one of the things essential to understand is just knowing where to pick your battles. So of course, if your area of interest or research is in AI itself, then I guess it makes sense to look into maybe coming up with your own model as an example. But if you are a novice and you just want to see how different model responds to your data, then like you said, I think it's good to look at those models and understand those limitations, right? Because otherwise you are potentially going into a rabbit hole.
Yeah, absolutely. Yeah, I think, yes, understanding what they can and can't do will help you a lot, and absolutely right, agree.
Great. And then in terms of what's new in data science and AI in general, are there any emerging trends you can share with us today?
Yeah, so I think, the hot trends happening now are more in the data engineering side of things,
Mm.
as we talked about, the information um and data is everywhere. The the volume is increasing, and all this data needs to be transported from one place where they originate to somewhere else where they will end up, and someone needs to make sure they get there, and someone needs to make sure it's right and it's fit for what they're trying to do, and it's and others, like me, can get access to it to do the analysis and stuff like that. So there is a lot of, interest in how do we get our pipelines to be um robust. How do we make
Yeah.
sure that they're doing what they should do? How can we optimize them? How can we make them even be able to do more? How can we ask more of them um than we already do right now? And on the other end, how do we house all these things? Where do we house them? And what model do
Mm.
we use to kind of house them? We've gone from, right, everything is in a single place. It's all like organized and stuff,
Distributed.
to
Yeah.
okay, everything in somewhere else, to everything in one place, but it's disorganized, and you write your own ETL. And there's so much going on in that world of how do we just transport our data from the origin to where it's going to live. How
Mm.
do we design that house where it's going to live? What's the
Yeah.
best way to design that house? And I think that's where a lot of the interesting conversations are happening now, because a lot of organizations have gone through, okay, we'll get in analysts, or we'll get in the people who will do the analysis, but
Mm.
hang on a minute, we can't even get access to what you want us to analyze. So there is
Yeah.
that whole thing there, where I think this is the key area in you know our field right now.
Oh, well, and that to me sounds like there's an organized effort to store data en masse and have something like a living library of different sets of data that can be extracted and used and applied in many different settings, which does sound exciting, but also sounds scary
Yes.
in a way, all of that data living in one place. And I guess it starts to bring to mind, things about, how we secure data, how we make sure only the right people are accessing the right amount and the right type of data, and of course, what people do with that data. Because I guess one thing about data is that it tells a lot potentially about people, about systems, infrastructure, how things are. Data is information,
Yeah.
right? So I guess, it's interesting you mentioned that as an emerging trend because it does make sense. But it also brings some worries. Personally.
Absolutely. And these
Yeah.
are the things that organizations need to work and work through. And organizations just need to also be mindful that what works for organization A might not necessarily work organization B. It's not
Yeah.
a copy and paste exercise. I think people need to work out what works for them, what is, but yeah, absolutely, it's a huge um challenge in industry, how all this kind of plays out.
Yeah. No, that's really good. And we're starting to get into the closing segments now. You'll be pleased to hear my questions do have an end. Don't worry. Um, so first question in the end segment is, what are the basic training you would recommend for anyone looking to pursue a career in data science?
Great question. So, data science, there's a lot of routes to entry,
Mm,
and it depends on what exactly you're interested in. But I would say what doesn't hurt, what everyone will need is that ability to extract data,
mhm,
ability to wrangle it, because if you don't know how to go to, as I said, this house where it all lives in, and you don't know how to pull it out to do
mm,
something with them, then you're not really going to do anything, right? So I
yeah.
think the first step, if I'll be thinking of learning how to extract um data, how to manipulate it, how to wrangle it, change the shape, change all sorts of stuff, transform it. So it's
Mm,
something like SQL, very versatile. SQL has been around for ages, and
mm,
it's not looking like it's going anywhere anytime soon, you know.
yeah.
So, and a lot of organizations, a lot of enterprises just rely on SQL. So I would say that's a good solid place to start, because if nothing else, at least you'll be able to pull some um, um, data, you'll be able to
Yeah.
wrangle it. And then the next thing you might want to think is, right, okay, I've got all this. How can I visualize it? Because visualization makes life so much easier. You're reading reams and reams of like uh, information, text,
Hmm.
numbers. It doesn't mean anything, but plot it
Yeah.
out, and oh my god, yeah, insights jump out at you. So that might be the next thing you want to think of. Right now that I can extract it, manipulate it, how can I visualize it? So again,
Mm,
a tool or a language that can make that kind of easy for you to do is probably the next kind of thing I would be thinking of. After that, I would say the third thing is, okay, once you've wrangled it, plotted it, visualize it, the next thing you might want to do is to interpret it.
mm,
So I can see a trend going up, but is it really going up? Or I can
yeah.
see that this average looks higher than that average. Is it really? Or, so I would start to think about at that point some basic um, statistical knowledge. So what we call hypothesis testing.
Hmm.
And to be honest, I genuinely believe if you can get that far, you can extract. If you can extract information, you can visualize it, and you can interpret it using
Yeah.
a statistically robust method. Then there's a ton of jobs that are so easily accessible that you could just walk into. And then all the other things can come on later, all the
Yeah.
advanced like machine learning or modeling and etc., that can come on the end. But I think for me, I would start there.
Good. Thank you. And more of a personal question, what do you love most about being a data scientist?
Yeah. So what I love most is the mentoring, meeting like uh, uh, um, uh, early career data scientists, and
Yeah.
people who are just new into it, and just kind of helping them, mentoring them, just showing them, okay, here are the routes, here are options, think about this, here's
Hmm.
that, and just give them that somebody to kind of you know have, if they need anything. I was um very very lucky. I had a great mentor, and
Hmm.
she was absolutely amazing, and she opened up my world to a lot of things, and I thought, wow. So I think for me, just doing that, I find it very exciting.
Oh, that is really excellent, Itoro. And I think we can bring things to a close on that point. Thank you so much for sharing your expertise with us on data science, machine learning, and artificial intelligence. I thoroughly enjoyed that. And I just want to say thank you from the bottom of my heart. This is what we're about as a platform, hearing from women in leadership and technical spaces, sharing their experience and also inspiring others to follow career paths in tech. So thank you so much for doing this today. And I hope everyone watching enjoyed this as much as I enjoyed listening to this. And yeah, I hope to see you all again soon.
Thank you very much. Have a
Thank
great
you.
day.
Okay.
Cheers.